bringing the KTS and was waiting for it to start, and it was all remote, and then suddenly realized I was chairing the wrong, trying to chair the wrong session. So that's not an auspicious start for me, but we will anticipate far more coherent and powerful work from our speakers today. So we start with Mirza, from Assyria to Amherst, which is quite a leap, a case of knowledge, diffusion, erosion, and local entrenchment. Thank you, Ali.
Thank you, everybody, for coming to our session. I broke everything. Oh, no, it's fine. Okay. Yes. So, in 1855, a series of gypsum slabs or reliefs had arrived in Amherst, Massachusetts, from the palace of Ashurnarpal II. These slabs were originally carved around 800 BC, and these photos are from the Mead Art Museum, where they are currently held. 6 of these sculptures were sent to Amherst by an American missionary named Henry Lobdell. On the back of camels and in the bosoms of ships, they did arrive in Amherst, unlike Lobdell, who died in Mosul in the spring of 1855. These wall reliefs were first documented by Austin Henry Layard. Layard interpreted the palace in which these sculptures were found as part of the biblical city of Nineveh, leading to numerous well-received publications. As Layard's friend Charles Allison wrote to him around 1847, write a whopper with lots of plates, fish up old legends and anecdotes, and if you can by any means humbug people into the belief that you have established any points in the Bible, you are a made man. And so he produced lots of books with, hundreds of plates. So 2 of these books were Monuments of Nineveh and Nineveh and its Ruins. Many American missionaries, unsurprisingly, noted this work and set out to locate and send many of the remaining slabs to America, with eventual destinations including Williams College, Amherst College, Dartmouth, Yale, New York Historical Society, and many, many more places. Lobdell is a particularly critical figure for understanding the arrival interpretation of these slabs. As Ada Cohen and Stephen E. Congus write, the Reverend Lobdell played a significant role in the acquisition of the Dartmouth reliefs. The circumstances whereby Lobdell, an Amherst man, came to assemble and pack the Dartmouth reliefs are not completely clear, but they seem extraordinary. Lobdell graduated from Amherst in 1849, so I want to focus on that location to ask a series of important questions. What made Lobdell likely to send slabs to American institutions? And more importantly, or what I will emphasize, is how were they interpreted when they arrived here? And that will help us determine the lenses through which 19th century researchers engaged with the mobility of knowledge and material culture. So some local context, mainly by way of a figure known as Edward Hitchcock. Hitchcock had served as professor of natural history and chemistry at Amherst College since 1825. 20 years later, he would become perhaps the most notable president of the college in its history, and he conducted the Massachusetts State Geological Survey, cataloging all manner of minerals, plants, fossils, animals, and sedimentary structures present therein. Despite the comprehensiveness of his survey, and this was around 1830, Hitchcock ironically entirely missed the geological feature that he would devote his life to studying, the sandstone footprints around the Connecticut River. Hitchcock would found not only the science of footprints and tracks called ichnology, but a cabinet of fossil traces that would support the new science, containing around 20,000 footprints. I previously noted 2 legacies of Hitchcock's work, the zoological and ethnological legacy, and that'll be important for setting kind of the background for further interpretation. So just very quickly in super clunky fashion, the zoological legacy was, so Cuvier in the early 19th century proposed laws of correlation that stated for an animal to function, every part must be coordinated in a very particular manner, right? So you can't have the teeth of a dedicated predator like a tiger without its claws and digestive system as well. Put the hooves of a horse on a tiger and it won't be able to catch the prey that it needs to eat, right? So these laws became a founding myth for paleontology, helping naturalists reconstruct fossils that had become mixed up, jumbled, or incomplete. Find a single-toed hoof, reconstruct a horse. Thus, Cuvier wrote, anyone who observes merely the print of a cloven hoof may conclude that it has been left by a ruminant animal and regard the conclusion as equally certain with any other in physics or morals, right? So that's a very strong statement. The consequence of these laws was that chimeras in particular couldn't exist. So Cuvier writes, Now, the greater number of these animals have an origin purely mythological. We see merely the different parts of known animals united by an unbridled imagination and in contradiction to every established law of nature. As Hitchcock proceeded to interpret the footprints he found in New England through covariant methods, he found that his footprint creatures were not so harmonious in form. So this is a great slab called Onomoipus, where this animal leaves these very bird-like footprints, jumps up, lands, and puts 2 hand marks on the ground with nice 5 fingers and a long tail. So of this, Hitchcock wrote, indeed, if a phrase so compound could be used as should imply a participation in the characters of marsupials, birds, batrachians, frogs, and even lizards, it would better than any other express my present convictions. For the longer I study these tracks, the stronger my impressions become that some of these ancient animals possess characters now more exclusively belonging to 2, 3, or even 4 classes. Of Autozoum on the left and Gigantotherium, he wrote, this animal must have been a match for the gorgons and chimeras of mythology. He even named the genus Chimera. And I love that one the best because it reminds me of those like jelly hand toys. And if you don't believe me, it's pretty close, right? So Hitchcock, in a subtle case of one-uppance, emphasized how chimeric functioning creatures were now simply undoubtable. At first, men supposed that the strange and gigantic races which I had described were mere creatures of imagination. He's talking about Cuvier, like the gorgons and chimeras of the ancient poets. He might as reasonably doubt his own corporeal existence as that of these enormous and peculiar races. The bird chimeras were the most notable in Hitchcock's footprint slabs, as the morphology of birds in the 19th century was the most isolated from other groups. So Darwin wrote to Hitchcock around 1841 in excitement, hoping that they showed some kind of connection between birds and amphibians. Hitchcock explained the anomalous forms of his footprint creatures as caused by environments being radically different from ours. Organisms in different periods had bizarre correlations from our perspective because they lived in habitats different from ours as the world changed drastically in its composition. The notion that aspects of the world were mobile, dynamic, and plastic was not new to the 18th nor 19th century. As Dina Dubbin points out regarding how a plastic view of nature was embedded even into the paintings of Hubert Robert, Robert's landscapes are perpetually overwhelmed by the dynamism of their surrounding. As such, they point to the great paradox of 18th century ruins, namely that it converted emblems of long-standing rootedness to the earth into fountainheads of mobility, chance, and precariousness. Chimeras extended these themes of mobility, chance, and precariousness into the last bastion of stability, life itself. While gorgons and chimeras symbolized animal plasticity, there was another form of plasticity that lay closer to the foundations of technology. Hitchcock learned that the correlation between an individual's actions and the impacts in the world that those actions led to were deeply unpredictable. There were all manner of important instances in which different organisms, actions, and causes could lead to the same effects, or the same cause could lead to different effects, known as the phenomenon of cross-realizability, known as in the sense that I just made it up, right? What I called it. So a good example is fish traces and wave ripples. So Hitchcock writes, once I hardly could have been made to believe that there was any danger of confounding fossil footmarks with ripple marks. But since I have attempted to work out the genus Telychnus as the tracks of fishes, this very question has occasioned me much perplexity. Tadpole nests and wave interference patterns were extremely difficult to distinguish. That's a Pandora's box I'm not going to open right now. Worm tracks and plants, another one. He writes, I refer to the annelid tracks. Some of these do so closely resemble certain rhythm-like fucoids or seaweeds that I found it difficult to distinguish between them. The same is true of certain insect tracks, and this was a very prescient note. Even footprints could exhibit cross-realizability, where the under track of the footprint of one creature could look like the true footprint of a completely different creature. There were endless forms of cross-realizability, and identifying traces was impossible without close analysis of this detail separating these phenomena. This meant that ethnology studied correlations not found or scrutinized by other sciences. So Hitchcock wrote, indeed, I've often been made to feel in these investigations that objects and operations in nature, whose typical forms differ entirely, as it were, become in certain abnormal conditions apparently identical. This highlighted a fundamental point about scientific expertise. Because these animal earth correlations were not studied by other sciences, ichnological methods or laws were reducible neither to Cuvier's anatomical laws nor Charles Lyell's geological principles. In the 1840s and 1850s, Hitchcock recognized that ichnology was turning from merely a science of tracks to ultimately a science of how an action correlates with a long-term geological impact. It revealed two important lessons even then. When an animal or a plant meets Earth, the effects of this can only be determined with an empirically rigorous science dedicated to impacts. And the footprint showed that what commonly remains is what you would think is the most delicate, a single step in soft mud, while what seems the most robust bones and bodies disappear with no notice. Despite thousands of footprints, almost no bones were ever found. So Hubert Robert, as Nina Dubbin wrote, converted emblems of long-standing rootedness to the earth into fountainheads of mobility, chance, and precariousness. Hitchcock did the opposite, converting emblems of the ephemera and the shadows of the living, the mere and literal chicken scratches on the margins of the rock record, into archetypes of stability and rootedness. For the faculty and presidents of Amherst College in the early and mid-19th century, issues around the science of impacts would cut through to their deepest insecurities. Hitchcock, for instance, had inherited a potentially ephemeral college on the brink of financial collapse. As his colleague William Seymour Tyler put it at the time, the causes of the decline of the college were discussed in newspapers and pamphlets and writers published to the world that the alumni were dissatisfied with the management. It never would prosper without a thorough reform, not to say a complete revolution. Those were dark days for Amherst College, days of cruel trial and suffering. The trial of living on a half salary a few years later was nothing in comparison. Some of them carried the sting of it to their dying day, and it still lingers in the memory of the survivors. These settler colonialists and their, drama. Amazing. The president prior to Edward Hitchcock, Keenan Humphrey, had resigned due to this exact public pressure. Williams College had been dangerously close to being moved itself. Even the Amherst College Charter evidences this, with Section 7 saying, if the president and trustees of Williams College shall agree so to do, the legislature shall have full power to unite Williams and Amherst colleges into one university at Amherst, and Amherst would have no say in this. The settler colonialists of Western Massachusetts during the mid-19th century were not under the illusions of geographical stability for their institutions and less for their own legacies. Knowledge itself was movable. Professors, books, and even libraries could all be relocated. This kind of local erosion would have been contrary to their, settling and colonizing, right? The fact that such delicate footprints could remain in the area for millions of years when the faculty and presidents were not only non-autochthonous, but also had no guarantee of persistence in the area would have spoken volumes. Unsurprisingly, many poems about the footprints emphasized exactly this, with Hitchcock himself writing, "Birds, a problem you have solved, man never has, to leave a trace on earth too deep for time and fate to wear away." The notion of not being able to easily removed has been discussed in the history and philosophy of science under the notion of entrenchment, right? So entrenched items are such an intimate part of a system that their removal becomes difficult without causing real harm or damage to the functioning of the system. Ichnology, of course, was for Hitchcock in part a science of entrenchment, being the true empirical measure of what the consequences of an action are for the discrete structure of the earth. To understand how the Assyrian slabs were interpreted, we need to look at Amherst in the 19th century through this 19th century entrenchment lens. To convince you how important this lens is as a historical method, I'll use it to rewrite a 70 and even 200-year narrative regarding one of the buildings on campus. Central here is the first building Hitchcock constructed called Wood's Cabinet, or the Octagon, during his presidency. There's a lot of simplifications in what I'm about to do, but we largely on track. This building is doubly important because it symbolized the college's later collections by being the first cabinet, and at different points the footprints and the Assyrian reliefs were held there. But they were split up almost throughout their entire history. They were never put in the same building, interestingly, but they were supposed to be. So what we know for certain, in 1846, the trustees of Amherst College voted for Wood's Cabinet to be built, and in 1847, Wood's Cabinet was built. This generally held history regarding the Octagon first traces to Stanley King, the 11th president of Amherst College. King wrote regarding the question of its shape, "Happily, we know the answer, and the answer makes an interesting story in itself." He took his architecture direct from an Amherst graduate, Orson Squire Fowler. Fowler had moved to New York after graduating from Amherst and was best known for his work on phrenology, sexual science, hydropathy, and was a co-publisher of the American Phrenological Journal. Fowler eventually published a book regarding the Octagon, of which King writes, while the first edition of the book in 1849 did not appear until 2 years later, after the erection of the cabinet, Fowler had been publicizing his ideas on the subject for many years. Regarding another smaller octagon outside of Hitchcock's house, King wrote, "An octagonal wing to this house had been added by Hitchcock shortly before the octagon was erected on campus." That was also called the Mineral House. So what we need to know is, when did Fowler have his idea, and when was the mini octagon made in front of Hitchcock's house? Those are dates we did not have. with accuracy previously. In short, Fowler didn't say when he had the idea in his book, but when he introduced the book before it was coming out in the American Phrenological Journal, he actually mentions that he had the idea somewhere after the spring of 1844. So far it's consistent with Wood's cabinet being built in 1847. However, I started combing through Hitchcock's payment receipts for the period and came across the following. And that is the receipt he got from a Warren S. Howland, which says, I have made a mineral home. Built a mineral home for him this year, and that's dated to 1838. That was much before Fowler ever had his idea. So the Fowler model as is historically intractable. Hitchcock was building octagons well before. So what alternatives will we have? Well, we never actually had one. And so this took a good deal of archival digging. So what really happened? Well, in his teens, Hitchcock took a class with his uncle, Major General Epiphras Hoyt, on fortifications. He taught a class on Amherst in 1828, and Hitchcock wrote a paper on fortification with wordings coming from his uncle's book. And essentially, what I'll just kind of simplify is his uncle talks a lot about military entrenchment and how important it is generally for like stabilizing a position. And we know that Hitchcock and his uncle were both motivated by the French architect Vauban. So essentially what happened was, around the 1840s, Hitchcock was declared as not the discoverer of the footprints. The college was in financial trouble, and Hitchcock was asked to teach a class on fortification. And the footprints had managed to be an indelible part of the community. Feeling surrounded on all sides by the threats not only to his legacy, but the college's, Hitchcock combined the symbols and objects that for him best exhibited a sense of security. I'll fast forward a little bit. So do not think, though, that Hitchcock was only interested in metaphors and entrenchment. The construction of the cabinets was a physical entrenchment process. For he reminisced later, these cabinets form an anchor to steady the college in stormy times. Such periods of trial not unfrequently come when the temptation is to give up the ship or transfer it to some other place. But though it be easy to transfer teachers and funds and even libraries, large cabinet buildings with costly fixtures cannot be so easily changed. So the Assyrian reliefs have to be interpreted through this lens. There are a few important things that they had to say regarding it. One was that in the slabs, there are chimeras, right? And notably, there are bird chimeras. For instance, William Seymour Tyler, Hitchcock's friend, wrote that in these forms, the ancient Assyrians were symbolizing all that is swiftest and strongest and wisest in nature. And through that, they were trying to approximate the mystery of incarnation. And these reliefs also spoke to entrenchment in three different ways, being considered the footprints of former generations of men. One, they were heavy, like the footprint slabs, so difficult to move. The second was their utility in highlighting settler colonial adaptivity. So, as Jean M. O'Brien puts it, Indians are categorically depicted as static and incapable of change. Even when considered measures had been taken to civilize Indians, they cannot survive in this state. Non-Indians, on the other hand, could and frequently did go native in habit and conduct and even nature. The Syrian slabs analogously emphasize settler colonial's ability to go Assyrian where other cultures could not. And Tyler has this whole section where he says, there are no infidels amongst the Muslim because you are not allowed to disagree with anything. Christianity alone invites investigation and says, come, let us reason together. By appreciating ancient Assyrian beliefs better than Muslims on the other side of the world, settler colonialists further self-justified their adaptivity, a precondition to become local in whatever locale. The third utility of the slabs was to further teach what remains and what doesn't over medium timescales. As soon as the slabs arrived, a fervor of activity was focused on etching thimbles into rock. And I can date these to coming after the Syrian slabs. The juxtaposition of natural history and human history is best evidenced, however, by one of the most bizarre slabs in the cabinet. And it's a bunch of footprints, notably of the most chimeric creature, Anamoipas, but presented by Enos Dickinson written on it. And he was not known for having donated any footprint slabs. He was, however, known as the person who paid for where the Assyrian slabs were held. This was an attempt to mirror the chimeras and entrenched etchings of the Assyrian reliefs and natural history footprints. The etching an experiment to construct an amplified Assyrian relief on steroids, the chimera underneath the text no longer mythological, but a real fossil specimen. For Tyler and Hitchcock, natural history, human history, paganism, and Christianity all used adaptation to suggest, approximate, or symbolize God's power to fit any of his creatures into a particular location, right? Wink, wink. I'll skip that. That's just some secondary literature context. Lobdell ultimately was an early product of such a system of education, one that eventually wove together collected physical objects that were difficult to move with pedagogical practices with objects that were difficult to forget. Etching in stone, chimeras, but also naming ceremonies for mountains, and Amherst Students Magazine's name, right there, ichnolote with footprints on top, and more are clues towards the numerous pedagogies used by faculty produce a unique cultural take on the manufacturing of stability in a world of uncertainty. That even the earlier pedagogies made a clear impression is well evident. So this is a letter from Lobdell to Hitchcock, where he writes, "This may at least intimate my deep interest in all that pertains to your happiness and the prosperity of the college, an interest which increases as I grow older, and especially when I remember that in Amherst my destiny was shaped." Letters also reveal that Lobdell ultimately considered Hitchcock his father in college, that he owed no more to no more man more than Hitchcock. The strategy, of course, worked, for as William Seymour Tyler put it, the history of his presidency, its value to the institution cannot be overestimated. His weight of character and his wise policy. We have said it publicly before, and we wish to repeat it and put it on record. His weight of character and his wise policy saved the college. So goes the story of how a cabinet of footprints, an octagon-shaped building, and a gallery of Assyrian reliefs was central to saving a college from financial collapse. Do I have time for a conclusion? Or no?
Go.
Okay.
And then we'll just maybe have to leave your questions to the break.
Cool. In a culture which increasingly sought universal knowledge, settler colonialists seeking to resist constant change turned to distant or deep time or autochthonous symbols of adaptability and perseverance for aid. A new science of fossil footprints, ancient Assyrian reliefs, military architecture, strategies, state resources, poems, Muslim-Christian relationships, indigenous practices and names, stone etchings, all were combined to elicit a manifold and codependent semblance of stability, which was then iterated or expanded through various pedagogies. To understand the true depth of these histories, we can't just use archival documents or objects, nor collections directly. For as much as we'd like them to, objects do not speak to us. We need to listen to those brief moments in which objects speak to each other, to listen bizarrely to the 19th century acquisition of Assyrian reliefs through the amplifier of a collection of fossil footprints. Thank you.
Fascinating. I think we have time for one quick question, if there is one. Yeah.
It's not really a question. I'm very interested in your presentation, but obviously you went too fast for us to really get a grasp of what you're talking about. Are you paid on that?
It's going to be chapter 3 of my book.
Okay.
So, okay, so I'm gonna move us along just so we do get our, get through the 3 papers here. Next. Our organizers are keeping us on a very strict and intense schedule. So we'll hope to have discussions after this to continue past our time. All right. And this one is the official. Did I lose it here? Sure. So while we're waiting for the talk to come up, one of the things that I admitted to say is where Ali is from, and not surprisingly, he's based at Amherst College, which is part in Massachusetts, which is part of the interest of the work as it developed. Fateme Savadi, our next speaker, is based at McGill University in Montreal and is going to speak to us about the most temperate region of the earth.
Thank you. And thank you for being here. Hi, everyone. Thank you. And I'm grateful for the opportunity to share my research. And I'd also like to express my gratitude to the organizers of the conference. In this talk, I examine a debate that took place between medieval Islamic scientists and philosophers on whether or not the equator has the most temperate climate of the Earth. The central figure in this debate is Avicenna, a famous philosopher and scientist from the second half of the 10th century and first half of the 11th. Avicenna argues that the equator is the most temperate zone of the Earth. In order to understand his argument, I will situate it in the context of similar discussions in ancient Greek science, which Avicenna was very likely aware of. Next, I show how Avicenna's view was taken up and debated by his medieval successors, focusing on the criticisms leveled by the 12th century theologian Fakhreddin Razi in his commentary on Avicenna's Canon of Medicine, as well as Nasiruddin Tusi's mediation between Avicenna and Razi in one of his astronomical works, and Qutbuddin Shirazi's intervention in his own astronomical work and his commentary on Book 1 of Canon of Medicine. So first, let me begin by a brief introduction of these four main figures. Avicenna was a preeminent and influential philosopher and physician of the medieval period, building upon Arabic adaptations and adaptations of ancient Greek philosophical and scientific works and their late commentaries. He assimilated in a critical and innovative manner the Greek heritage into his own philosophical and scientific corpus. Avicenna's corpus not only dominated the Islamic world, but also influenced enormously the medieval and Renaissance thinkers of the Christian world. Scholarly engagement with Avicenna's corpus initiated a subsequent commentary tradition. One of the major figures of this commentary tradition was the famous skeptical theologian Fakhreddin Razi, whose commentaries on Avicenna's works were very critical. In his commentaries, Razi often assumed a contrarian stance, reflecting on a centuries-long and nuanced discourse between theologians and philosophers and the pre-modern Islamic world. Nasiruddin Tusi was an influential scholar in the fields of mathematics, astronomy, medicine, philosophy, and theology. In philosophy, Tusi's teachers, in philosophy, in mathematics, natural philosophy, and Avicennan philosophy, and medicine, his teachers, Nasiruddin Tusi's teachers, were actually pupils of Razi. However, Tusi became a loyal Avicennian, and in his commentary on one of Avicenna's philosophical summa, he systematically defended Avicenna against Razi. Qutbuddin Shirazi is perhaps the most known student of Razi, of Tusi, and he was a prolific writer and composed many works in various fields such as astronomy, mathematics, medicine, philosophy, etc. Shirazi was a practicing physician himself from a family of physicians and wrote an extensive multi-volume commentary just on the first book of the Canon of Medicine by Avicenna, which concerns the natural philosophical and theoretical foundations of the study of medicine. Now, before going over Avicenna's argument for the equator being the most temperate zone, we should situate the problem in the context of the Greek scientific and philosophical traditions. The influence of the climate on physical and intellectual developments of people and their health and disease was a fundamental notion in Hippocrates on airs, waters, and places. Hippocrates' text was transmitted to pre-modern Islamic world through the Arabic translation of Galen's commentary on it, and became very influential in the Islamic medical tradition. Hippocrates' work is perhaps one of the oldest examples of the integration of geographical and meteorological discussions into the study of medicine. Now we turn our attention to another context of this discussion, the meteorology. In his Meteorologica, Aristotle adopted Parmenides' division of the surface of the earth into 5 climatic zones. 2 were habitable zones, one in which we live towards the North Pole, and the other towards the South Pole. The zone in which we live is bounded by Tropic of Cancer and the Arctic Circle on the north. The other between the Tropic of Capricorn and the Antarctic Circle. The zone between the tropics was considered as uninhabitable, and because it was too hot there. And then lastly, the zones beyond the Arctic and Antarctic circles were considered uninhabitable because of the extreme cold. Aristotle's Meteorologica also deals with natural philosophy, astronomy, and geography and geology. Discussions of the source of the heat on the earth, 4 seasons, atmospheric events such as formation of clouds, rain, hail, etc. in Meteorologica 1 are examples of overlap between astronomy and meteorology because they have to do with the apparent motion of the sun in the sky. And its position with respect to various latitudinal divisions of the earth. One of the most important factors that determines the seasons is the intensity of the sun's rays over a given region. So you see here in figure 1, when the sun's rays strike the Tropic of Cancer at right angles, you see here, and it's basically the time when it's around June 20th to 22nd for the summer solstice for the people in the northern hemisphere, and winter solstice for the people living in the southern hemisphere. Figure B shows when the rays of the sun strike at right angle the Tropic of Capricorn, and it's around December 20th to 22nd, winter solstice for people in the north and northern hemisphere, and summer solstice for people at the southern hemisphere. And figure C is when the sun rays strike the equator at right angles, or which is autumnal equinox in the northern hemisphere and spring equinox in the north. Autumnal in the south, and spring or vernal equinox in the northern hemisphere. So we see that the most important factors in determining the heat at various locations are either the angle of the angle at which the sun's rays strike the surface of the earth and the length of the daylight. Okay. Greek knowledge about the extent of the inhabited world and the meteorological and astronomical phenomena that are peculiar to the Earth's various regions culminated in the works of Ptolemy. Ptolemy and his Greek predecessors were all aware of the fact that all localities with the same latitude have the same length of daylight. Based on this fact, the notion of climb was introduced. In the context of astronomy, climb means the inclination of the Earth's axis with respect to the plane of the local horizon. This notion defined a set of parallels, usually 7, on the surface of the Earth, whose values of longest daylight form an arithmetic progression. The 4th climb was generally considered to be the most temperate zone of the Earth. And its conditions for development of life and civilization were considered as being optimal. As one moves to the north and to the south, the situation gradually becomes less favorable, and this didn't change this idea of the 4th climb being the most temperate zone when the Greek heritage was adapted by the scholars of pre-modern Islamic work, who also were mostly living in the 4th and 5th climes. Ptolemy Ptolemy elaborated on the theory of climes. In the Almagest, Ptolemy increased the number of these parallels to 33, ranging from the equator, where the longest daylight is 12 hours, to the latitude, where the longest daylight is 24 hours. For each parallel, he recorded measures such as the longest daylight and angles of shadows casted by a new moon during the noon of the 2 equinox days and 2 solstice days. With this information, the reader of Almagest will have a sense of the apparent path of the sun in the sky of any certain region. Ptolemy also mentioned general characteristics of these parallels, with that of the equator being the longest. Ptolemy's opinion about the possibility of habitation along the equator is at odds with Aristotle's and the rest of the Greeks. Ptolemy is the earliest known source to convey the idea that the equator is the most temperate zone. Although it should be noted that Ptolemy did not explicitly accept this position, rather he conveyed it by citing an unnamed source, yet Ptolemy also did not reject the idea. So he says in the Almagest that it is said that the regions beneath the equator could be inhabited, since the climate must be quite temperate. For the sun does not stay long in the neighborhood of the zenith, since its motion in declination is swift round about the equinoctial points, and hence the summer would be temperate. Furthermore, it is not very far from the zenith at the solstice, so the winter would not be harsh. But what these inhabited regions we have no reliable grounds for saying, for up to now they are unexplored by men from our part of the inhabited world, and what people say about them must be considered guesswork rather than report. In his Geographia, however, Ptolemy determined the southernmost boundary of the known inhabited world to be a bit more than 16 degrees below the equator. Although we do not know Ptolemy's source for the view of the equator being the most temperate zone, perhaps Avicenna knew it, or maybe he just learned about it through Ptolemy's Almagest. In his various works, Avicenna dismissed the idea of a torrid zone between the 2 tropics. However, he argued that the regions along the 2 tropics are the hottest regions, whereas the equator, which falls between the 2, has the most temperate climate. In this respect, Avicenna agreed with Ptolemy's source that the equator has the most temperate climate because their sun reaches the zenith suddenly and moves away from it quickly. And daylight and night are equal in length, so it never reaches extreme heat or extreme cold. Avicenna also argued that people at the equator experience a uniformity in climatic condition. Avicenna's position was debated by his medieval Islamic readers. Fakhreddin Razi, who wrote critical commentaries on a number of Avicenna's works, argued against Avicenna's position. Razi believed that regions along the equator are actually the hottest regions of the world, since the sun is almost always overhead. However, he agreed with Avicenna that the people at the equator experience a uniform climatic condition. According to Razi, the 4th clime was the most temperate region. Nasiruddin Tusi also weighed in on this issue in his work on theoretical astronomy, effectively reconciling between Avicenna and Razi, saying that if one means by the word temperate a uniformity in conditions, then there is no doubt that it is most so at the equator. But if one means by it moderate weather conditions, then there is no doubt that it is more so in the 4th clime. Tusi's student Fateme Shirazi surveyed and summarized the debate between his predecessors and provided his own comments. Shirazi raised objections against Razi's arguments and at the end endorsed Tusi's judgment. Here is the main part of Avicenna's argument, which we see is it is based on a natural philosophical proposition for which he provided a Proctor-Creed proof and 5 Kia proofs. So the principle that he uses, the natural philosophical principle, is that the intensity of heat may be due to the power of the heat maker or to the continuity of heating. Even if the heat is weak, if it's continuous, it can produce a lot of heat. The effect of a weak cause may be stronger if its duration is longer than the duration of a strong. The Proctor-Creed proof is if a cause produces one effect during one period of time and continues to exist during another period of time, another effect will be produced and added to the previous one. Thus, the longer the cause remains, more effects will be combined, and the stronger the final effect will be. And then he supports his argument with these non-demonstrative proofs that the sun's heat is greater in the latter half of the July, even though it is farther away from the zenith than the summer solstice, while it's closest to the zenith. And the sun's heat is greater at a certain declination after summer solstice than when it is at the same declination, but before summer solstice, or the sun's heat is greater 2 hours after noon than 2 hours before noon, even though its distance from us is the same in both states. Or if a body is heated in a weak fire for a long time, it will be hotter than if it is heated in a strong fire for a moment. Or the cold in the early morning is greater than at midnight, even though the sun is farther away at midnight.
Just 2 more minutes.
Oh, sure. So the main thrust of Razi's arguments in denying Avicenna's position is that the regions along the two tropics are the hottest was to diminish the weight Avicenna gave to the length of summer days in making a region hot. Razi explicitly said that the length of the day has an insignificant influence in making the atmosphere hot, and argued that for every long summer day, there is a long winter night with the opposite effect, namely coldness. He then mentioned the polar day and night as examples of extremely long summer day and long winter night. But Shirazi rejected Razi's argument on the grounds that the crucial factor in the case of pole is the concentration of the sun's rays, somehow implying that the pole is a special case. Shirazi continued by adding that at the pole, due to the extreme farness of the sun from zenith, its rays hit the Earth's surface at obtuse angles, therefore they don't concentrate, but become scattered and diminished. So thus they weaken the heat production significantly. Shirazi then accused Razi of committing the logical fallacy of correlation versus causation, which involves assumption that one variable causes another when they are merely correlated, meaning that Razi assumed the length of the day as the cause of the heat, whereas Avicenna didn't mean that. Another argument by Razi is that for localities whose latitude is twice the obliquity, meaning 47 degrees, when the sun is in maximum declination, its distance from the zenith is the same as the equator, with one difference. At the equator, even though the sun lingers over the zenith only briefly, it nonetheless is never too far from being directly overhead. So heating comes after heating, whereas in the assumed locality, at other times, the sun is even farther from zenith, so the heating effect does not accumulate. Razi then added that the summer still feels hot at the assumed locality, so how hot it can be at the equator, where even the winter is hot, and the sun almost always is overhead. Shirazi's response to Razi is, one, it has two parts. One, the summer heat at the assumed locality is greater than the equator due to the long daylight and short night time. Second, Razi cannot appeal to people's feeling because people at the equator are accustomed to the heat to the point that they may not find the weather hot while the sun is over the zenith in the spring and summer, or may find it cool when the summer is at the solstice. Unlike the people of the assumed locality whose disposition is not accustomed to the heat, and who may find the summer very hot. So,
So I'm gonna have.
sure, sorry. So to conclude, I would say that we just saw that in the Islamic context, the debate regarding the most temperate zone became more nuanced, and scholars aim to provide philosophical reasons for it, and people feel free to criticize each other. And Shirazi basically try to provide references for the argument of each scholar, and then raise his own objection. And in this way, the debate we have examined reflects many of the distinctive feature of these post-classical Islamic philosophical and scientific traditions. Thank you.
An extraordinary series of arguments about astronomical determinism. Thank you. We'll keep our questions for Fateme until after the break, so that we have our final speaker of the session. And I do want to say where you're from while we get that up.
Yes, so hello, good morning. So my name is Milada Sekyrková. I am from Prague, Charles University, Central Europe. Yeah, and thank you very much for inviting me to this conference. So now I will speak about completely different region that we have heard now. And I turn your attraction just to Central Europe. And I would like to mention something about the languages in which was developed science in our region, and about such variability of the languages, and I will focus on English. When English appeared in the science language in our territory, because now it's common, everybody speaking English, it's common when it's an international conference is done, it will be in English, yeah. But for many people in many parts of the world, it's new, yeah. It's just since centuries only, not since centuries, since years can be said. In our region, for example, it is less than 40 years when English appeared as a common language of the science. Well, so I have to start with a short overview, and how to. It doesn't move. I'm sorry. Oh, here. Let me show you. I start with a short overview of the time. I have to start in the Middle Ages, but very briefly in different periods. I bring example in which languages was produced the science there. And so then I focus on the 19th century, because my field of interest is the long 19th centuries under our condition. It means from Enlightenment period up to the World War I. And I will bring in each period an example of the language, and it will be about circulation of the science in this time. So I have to start in the Middle Ages, of course, when the science was developed mostly by the monks in the monasteries. So it was time of Christianization of the region. And there are very good example from the Czech, from Bohemia, because in the past country was called Bohemia, and you find it everywhere, only like Bohemia. And a very good example from Middle Ages about transmission of antique knowledge is Chronica Bohemorum, which was written in Latin, and where is some places mentioned. So as well this antique knowledge. For example, when the author of the Chronic, who was very famous monk Cosmas, mentioned so foundation of the country. So they bring a case example about the lady which was called Kazi, and he was something for him like successor of Asclepius, and in this and many other consequences there is mentioned as well this antique knowledge, which this way arrived as well to our region. So the Latin was not only the language of the science at the time, despite mostly it's spoken only about Latin. But by the way, alongside there was as well a Jewish community living. And since very early modern time, Jews were lived in ghettos, and they have special education. There was education in Hebrew and in these Jewish communities in Europe. So the knowledge, the antique continuation, I would say, was more open than in Christian community at the same time. So it is necessary just to mean here this second language of the knowledge in Central Europe. So this Hebrew. And there is only one example, name of Yehuda Liva ben Bekalel, which is named as Maharal, for example, and he was a very distinguished scholar, and he was one of them in Hebrew as well, went on in the knowledge. We are ever speaking only about transmission, about conserved science, I would say conserved knowledge, because something new appeared only in the Baroque time in our conditions. So Baroque time, it was under strong Catholic supervision. It was time when Bohemia was already part of the Habsburg monarchy. There was a Catholic religion as the main state religion, but by the way as well, so some new directions in the knowledge appeared, and it was especially in the sciences, where was more open to search something new, so where the Catholic theology was not so strong in supervision of people working in that fields. And the first encyclopedia we can say about knowledges about the Bohemia was the work of Bohuslav Balbín, which was again written in Latin and which is known as Miscellanea Historica Regni Bohemiae, diversities from the history of Czech Kingdom, but it's not only about the history. So he planned to do in some series, so volumes which were dealing with many fields. So it was not only description of the country, it was description of our common knowledge, which was known there, and mostly it was written in Latin. But now we slowly are switching in other language, yeah. So, and the third language of the science which appears here, it was German, of course. So German came with Enlightenment period, and it was strong change. So from Latin to German, when change from one year to the next one, education at universities, yes, so where new order published. And Latin didn't disappear. So Latin was kept in the theology, in medicine, of course, yeah, but for other fields was done that the education will be kept at university level and as well in the scientific societies in German. So it's time when it appears in our country first scientific societies. As you can see, the first one had still a Latin name, Societas Incognitorum, very shortly working only, but publishing in German already. All publications were in German, and other societies were, despite there is English name, yes, so were German speaking with German production, and the main aim of these societies at the time was exchange publication with other countries. And thereafter, so Napoleonic War changed again. I would say also feelings and changed very much situation because started censorship in the Habsburg monarchy, travel ban for the most of people. But what about English? So because at the start I told I will focus on English, and just now it is the moment when English is coming on the stage, despite it doesn't look. But alongside with Enlightenment arrived the Industrial Revolution. And the main country where happened something interesting for people in Central Europe, it was England. And the travel ban was not for all kinds of level of society or groups of society. There was one group of people who was able to travel, had money, was not prohibited to go abroad, and it was aristocracy, nobility who before was watching to other parts of Europe. So young noblemen, so from Central Europe, since centuries were traveling to learn in Italy in French. And in this moment, yeah, so appeared a new field, new area, which started to be interesting for such kind of people, because they wanted to establish new factories. They wanted to learn something new in the sciences, especially, and in technology. And it was England, yeah, which was interesting for them. And again, one example, so very famous is your journey of Johann Adolf Prince of Schwarzenberg. Schwarzenberg, one very, very distinguished European noble family. And he visited several times England. Yeah, it was such kind of industry espionage, because he officially visited such culture places, castles, and so noble families in relation to his family. But by the way, we visited as well many factories. So he visited many interesting constructions. And about all this, he wrote very detailed remarks. And because the terminology was, he wrote in German, of course, yeah. He wrote in German, but he did many remarks in English, because for many terms he didn't know German terms, yeah, didn't exist at the time. So that's why, so a lot of remarks written by him are in English, yeah. And it was not only him. We have many journeys, records from other noblemen, and then first traveled alone, and then later they paid engineers, they paid scholars to go to England, yeah, and to bring to us. So their remarks, again, their drawings and their knowledge about British innovation. But it was only one field which was very special for this kind of people. The main language of the knowledge towards abroad became French in this time. French. So the France was ever so big example for nobility. And if people wanted to be up to date towards outside, towards abroad, so they had to speak French. So that's why it's another language which everybody who wanted to be able to communicate outside, to communicate with other scholars already, and other people had to learn. Here is another example in French from other noble family, when the very again distinguished administrative men, yeah, in Bohemia, so wrote the remarks about expected knowledge from his future wife when we wanted to get married, yeah. So he wrote many pages, yeah, about different fields in l'histoire and la géographie. There are as well remarks about the mathematics, physics, about languages, which he expects that his wife will know, yeah. And before the marriage, yeah, so he gave it to her. And then he as well examined if she knows something about it. Yeah, so we have again many remarks about it in our archive. There is a lot of such memorandum remarks and such documents in this field. So it is next language which people wanting to be up to date had to know. So, and another way was creation of the local Czech terminology. So again, special case, because Czech terminology in the sciences didn't exist. So the official language was German, but during Czech revival, yeah, so was created new Czech terminology, which later became so big achievement for our local science. And Czech terminology in sciences was made mostly by translation from German. So German has very specific terminology. In many cases, it's not translation from Latin. Yeah, they have their own. And if Czech terminology is made up to German, it's completely different, yeah, from other languages, which mostly have Latin ground. So here is one example. So silicium, yeah, in German, Kiesel, in Czech, křemík, yeah. So such kind is in different, mostly in the sciences. In sciences, of course, not in history. not in humanities, but in the sciences. The Czech scientific terminology is very specific, which is made up to German. So it is the next language with the second half of the 19th century people had to learn. And there are brother Pressels, which are which are authors of the most of this chemical and other nomenclature in the sciences. So from just from mid of the 19th century, so the science was as well developed in the national languages. So specific of the Habsburg monarchy was, then there was one official language, German language, but in the historical countries was spoken their own languages. Yeah. So and that's why there were developed just in this time universities. So working in the national languages in Prague, it happens in 1880s when the university divided in Czech and German speaking. And the Czech science went different way than German science, because Czech university and Prague became the top for local scholars. And German university became something like transit university for people who wanted only go through or started a career in Prague and went on to Vienna, to Berlin, and to other German-speaking universities. So appeared another language which was already at the high level, Czech language, I mean, and together with German, Latin, and French, and where is English? Yeah, so English didn't disappear, but it was kept under such conditions. So English was an optional language, the grammar schools already in this time, with a practical focus. It means when the boys wanted to develop studies at technical university, had already option on this kind of grammar school to learn English. Not at the classic colleges, gymnasia, not there was only Latin and Greek. So at the university, there was a field of study of English language as well, but it was mostly focused on translation of the literature from classic English and American literature, yeah, so not for practical reason. So that's why English was as well something side, not important yet, but there appeared, and now I bring only two examples, there are such more, and two fields, when English already at the turn of the 19th and 20th century became quite important. First of them is anthropology. So in Washington, in the US, lived since his childhood Aleš Hrdlička with his family. Family left the country, so and Hrdlička studied in America already. So he achieved very high education level, and he became administrator of anthropological collections in the Smithsonian Institution. But he never left the country, or he never left the touch with country, I would tell. And during his anthropological researches around the world, he divided his collections between Smithsonian and Prague. So already from the end of the 19th century, so we have in Prague at the Czech University very large collection coming from Hrdlička, yeah, which is consequent to the Smithsonian collections. And all the time he was in touch mainly with his colleague Jindřich Matějka, who was a professor of anthropology in Prague, and there is a large correspondence between them, having many hundred items, and a part of this correspondence is in Prague, other part is in US, and so there is described from one side Czech, from other side English, later Hrdlička switched as well in Czech language only. So there is described all his work around the world. So he described where he is going, so what he is bringing, how he divided all. There are very, very detailed receipts, for example, how much he paid for sending this to Prague and for sending there, etc. And in the letters, we can as well read very futuristic vision about English for Czech people. So it means already, so this is 1920, immediately when Czechoslovakia founded. So he writes how important is English for Czech communication with the world. And in Prague is a small Hrdlička museum. And the final case is a case of Jaroslav Hejrovský. It is one of very few Czechoslovak Nobel Prize winner, and it was chemical. And he first studied in Prague, but their electrochemistry was not so developed. So that's why, thanks to his family, because he came from the family of professor of law at the Charles University. So when studied to England, to the University College, and he wanted to stay there, finish his studies, but because in the summer 1914, so started the war, and he was just on holiday in Prague, he had no chance to go back to London. And he had to stay in Prague, so he was a soldier during the wars, of course, survived, and later he stayed in Prague, but he was ever in touch with English colleagues. And then in 1922, he described polarizography, and only much far later he was awarded by Nobel Prize winner. So it is case when it didn't start the war, he sure stayed in England, and maybe so the Nobel Prize was to the UK, yeah, but maybe in history doesn't exist. Well, conclusion already. So Central Europe is a complex area from the point of view of the language and science. So from the 18th century, new college spread here in many languages. The topic of scientist papers were not only local, but also of much greater importance and impact if they were written in generally more accessible languages. Scientists from the region usually achieved world-famous results only when they went abroad and published there, or when they had contacts abroad. English prevailed only after 1990. Before that, due to influence of culture, orientation, and politics, science was between two wars. Now it means mostly oriented towards French, and after the war toward Russian. Yeah. And last really conclusion. So development of science has been a great achievement, but it's handicapped for contact to abroad. Yeah. Because local people are very happy and have a terminology in their own languages, so it is at such level, which is not bad, yeah. But the communication abroad is to learn other languages, to translate, and to be able to communicate with people abroad. So thank you for your attention.
Time for a couple of questions. One brief addition to yours is my uncle was Czech, and in 1936 or 37, he was 17 or 16. He already spoke German, Czech, and French. His father took him out of the city to stay away to the countryside for a few months to teach him English, so that he could then in 37 or 38 escape to England. They were Jewish background. So the English is like the passport by the
example.
yeah, by the. Thank you. Are there any other questions or comments?
Yeah, that was really a fascinating case, partly because there's so many different languages that people have to learn at different periods. And clearly there are disadvantages of that kind of system. But I wondered if there's also, at least in some fields, advantages as well, in that it makes people who have had that kind of background more cosmopolitan. I mean, I come originally from the Midwest in the United States, which was very monolingual, and it meant that people were often very unaware of different cultural traditions in science and unable to draw on that.
Oh yeah, so there is now children or young people learn English, yeah. So this now it's very easy to speak for them. So and be cosmopolitan, I would say, in all fields, because they are able to speak about different items in English, learning English, and so yeah. But in the past it was different, and so now I think the country since 1990s, yeah, it's cosmopolitan, it's open, yeah, so but if it's any special field more or less, I'm not sure.
But is there a benefit from knowing French,
Yeah.
German, other languages, Russian?
Yeah,
as well?
it's a benefit for my generation, yeah.
Yeah.
For younger generation, it's problematic because they can check in English mostly, yeah. It's not enough. So if people, so they have to learn two foreign languages. Yeah, there is, for my generation, the duty was Russian and then another one. Yeah, now there is no duty, but mostly English is the first one. Yeah, and the second they have to learn, and not everybody is happy to learn it. So it's also, yeah. So we can say that this generation will get to bilingual Czech and English, yeah, and about other languages, up to fields. If they are attracted by any country or yes, so any territory, so they learn the language. If not, so only Czech and English.
Well, thank you to all of our speakers, and I hope there'll be opportunity in the hallways or on the way down to coffee or during coffee to ask further questions we want to ask about these interesting papers.